Imagine a vast hidden network beneath our feet, fiery arteries of molten rock connecting the Pacific Northwest's most iconic peaks. It's a vision that sparks the imagination, a secret world where the region's most famous volcanoes are not isolated, but part of a single living system, pulsing with energy deep below the surface. Mount Rainier, Mount St. Helens, and Mount Hood, towering above the landscape, each with its own story yet seemingly standing together as sentinels of the Cascade Range. The idea of colossal magma tunnels linking these giants is the stuff of legend and disaster movies, conjuring visions of synchronized eruptions, reshaping the region overnight. It's a scenario that has inspired countless books, films, and even local folklore, fueling both awe and anxiety. But are these mountains truly connected, or are they solitary giants, each with its own isolated heart of fire? Are they part of a grand design, or simply neighbors shaped by the same powerful forces? The allure of a grand, interconnected system is powerful, feeding our fascination with the planet's hidden forces. It's easy to see why people are drawn to the idea. After all, the Earth's interior is still largely a mystery, and the unknown always invites speculation. We see these volcanoes as part of the Cascade Range, so it's natural to wonder if their origins are linked in the most direct way. The mountains form a dramatic chain, stretching for hundreds of miles, hinting at a possible connection beneath the surface. Rumors of magma tunnels often spiral into dramatic tales of impending doom, but what does science actually say? Are these stories just myths, or is there a kernel of truth hidden within them? The reality is that the ground beneath us is dynamic, shaped by immense geological forces over billions of years. Tectonic plates shift, magma rises and falls, and the landscape is constantly being rewritten by the slow but relentless power of nature. The idea of interconnected volcanoes taps into our primal fear of the unknown, but it's also a question of public safety for millions. Understanding whether these giants are linked could change how we prepare for future eruptions and protect the communities living in their shadow. That's why scientists at the USGS are on a mission to separate fact from fiction, using every tool at their disposal. From seismic sensors to satellite imagery, they're piecing together the puzzle of what lies beneath the Cascades. So, let's dig into what these scientific detectives have discovered about the true relationship between these volcanic peaks. Their findings might surprise you, challenging old assumptions and revealing new mysteries. As always, the truth is more nuanced and fascinating than any myth. The story of the Cascades is one of complexity, wonder, and the ongoing quest to understand the forces that shape our world. So, do magma tunnels connect Rainier, St. Helens, and Hood? The USGS's answer is clear: no. Despite captivating stories, comprehensive surveys, seismic imaging, ground deformation studies show no evidence of a continuous magma conduit linking these volcanoes. Each has its own unique magma reservoir, miles beneath its summit. The confusion comes from misunderstanding how volcanoes are related. They exist because of subduction, not because they share a single magma source. The Cascade volcanoes are siblings in a geologically active region, but each has its own house, its own plumbing. Studies, even as recent as 2025, confirm that each volcano's magma system is distinct, shaped by local conditions. The myth of interconnected tunnels is just that, a myth. Understanding this distinction is crucial for assessing real volcanic hazards and moving from fear to informed awareness. These volcanoes are neighbors, not conjoined twins. To understand why the magma tunnel theory doesn't hold up, let's look inside a volcano. The reality beneath the surface is far more complex and fascinating than a simple underground passage. Forget the idea of a simple pipe from the Earth's core. Volcano plumbing is a tangled, ever-changing network. It's a dynamic system, constantly shifting as pressures build and release, and as new cracks form in the crust. Deep below, a magma chamber is more like a slushy sponge than a cavern of lava. It's a mixture of molten rock, crystals, and gases, all squeezed into porous rock, not a vast empty space. Magma rises through cracks, forming a web of dikes and sills, not a single open tunnel. These intrusions snake their way through the crust, exploiting every weakness and fracture they find. The journey upward is slow and violent, with magma breaking and melting rock as it goes. Each eruption is the result of years, sometimes centuries, of this relentless struggle. A continuous tunnel stretching over 100 miles would quickly cool and solidify, making such a connection impossible. The rock would harden, blocking any flow long before it could reach another volcano. Each volcano is fed by its own evolving system, shaped by local weaknesses in the crust. These systems are unique, responding to the geology and tectonics of their specific location. That's why Mount St. Helens, Rainier, and Hood each have unique eruptive histories. Their paths are written by the individual paths magma has carved beneath them. Their behaviors reflect their individual, separate plumbing. No two volcanoes erupt in exactly the same way because no two have the same underground structure. These are geological individuals, not parts of a single machine. Each stands alone, shaped by millions of years of unique geological processes. The evidence points to independence, not interconnection. Studies of magma chemistry and seismic data confirm that each volcano has its own distinct source. Each volcano's story is written in its own stone and fire, a testament to the individuality and power of these natural giants. With the tunnel myth set aside, what's the real status of these volcanoes? Let's take a closer look at what's actually happening beneath the surface of these iconic peaks. As of September 2025, the USGS lists Rainier, St. Helens, and Hood at their lowest alert level, normal or green. This means there are no signs of unusual activity or increased risk at any of these volcanoes. This means they're in a non-eruptive state, showing only background activity. Tiny earthquakes, steady gas release, and no significant ground changes. These subtle signals are typical for dormant volcanoes, and are closely tracked by scientists. Think of it as a sleeping giant's gentle breathing. The volcanoes are alive, but their movements are so subtle, most people would never notice. These signals tell scientists the volcanoes are alive, but not stirring. Teams of experts regularly check data from sensors, satellites, and field observations to ensure nothing is missed. For comparison, Kilauea in Hawaii is currently at watch orange, meaning an eruption is underway or imminent. The contrast is dramatic. Kilauea's activity is visible and ongoing, while the Cascades remain calm. The difference between green and orange is the difference between calm and crisis. Green means business as usual, while orange signals urgent attention and possible danger. The fact that the Cascades are all green is the most important message for the region. There's no immediate threat. Residents and visitors can enjoy the beauty of these mountains without worry. The USGS constantly monitors and updates these alert levels, ready to respond if anything changes. Their vigilance helps keep communities safe and informed. For now, the giants are sleeping peacefully, watched over by science and the people dedicated to understanding their every move. News of earthquakes near a volcano can spark anxiety, but context is key. In July and August 2025, small quakes were detected at Mount Rainier, normal for active volcanic regions. Most of these tremors aren't signs of magma on the move. They're caused by shifting rock, moving water, or even glaciers. These are the creaks and groans of a living mountain, not the roar of awakening. USGS scientists analyze not just the number, but the depth, location, and type of quakes. Only certain patterns, like swarms of deep long-period earthquakes, signal real unrest. The recent activity at Rainier was just background noise, consistent with years of monitoring. Not all seismic activity is a warning sign, it's the pattern and intensity that matter. The low-level rumbling is simply a reminder that these volcanoes are dormant, not dead. How do we know these volcanoes are sleeping? Thanks to a sophisticated network of instruments, the USGS keeps constant watch. Seismometers detect tiny ground vibrations, listening for signs of magma movement or breaking rock. GPS stations track subtle changes in the volcano's shape, revealing swelling or deflation as magma moves. Scientists also monitor volcanic gases. Changes in sulfur dioxide, for example, can signal rising magma. Data from these tools combine to create a comprehensive health report for each volcano. This multi-layered approach ensures even the slightest symptom of unrest is detected early. The result: confidence in the volcano's current calm. Science is our early warning system. Let's imagine, what if these volcanoes were connected and erupted together? A triple eruption would be catastrophic. Pyroclastic flows, lahars, and ash would devastate communities and infrastructure. Ash clouds would halt air travel and ruin crops across the continent. On a global scale, massive sulfur dioxide emissions could trigger a volcanic winter, cooling the planet and disrupting food supplies. This scenario, though pure fiction, highlights the importance of understanding the volcano's independence. The real risk is not a synchronized disaster, but the unique hazards each volcano poses. Science shows us why the myth of a triple eruption is just that, a myth. Knowledge is our best defense. The idea of a triple eruption is terrifying, but it's science fiction. Decades of USGS research show these volcanoes stand alone, not connected by fiery tunnels. This understanding isn't cause for complacency, but for respect and preparedness. Our greatest tool is knowledge. Constant monitoring forms a sophisticated early warning system. Unlike earthquakes, volcanoes usually give signs before erupting, providing time for warnings and evacuations. The 1980 Mount St. Helens eruption proved the value of scientific forecasting, saving lives. Today's monitoring is even more advanced, offering longer warning times. The USGS's mission is public safety, not panic, providing clear, reliable information for communities. As of September 2025, alert levels are green, background rumbles are normal, and there are no secret magma tunnels. We can appreciate these mountains' beauty, trusting the science that keeps us safe in their shadow.